Hello everyone! Welcome to Grade 11 General Mathematics. We are still in Module 3 and we are now in Operations of Function number 5. That is the composition of functions. In composition of functions, we will have a lot of substitutions. You learned in previous lesson that to evaluate a function, you will just substitute a certain number in all of the variables in the given function. Similarly, if a function is substituted to all variables in another function, you are performing compositions of functions to create another function. Some authors call this operation as function of functions. Now, here is the definition. The composite function denoted by f so we have here open circle. That is the symbol for composite function is equal to f at g at x. The process of obtaining a composite function is called function composition. So let's have here an example. Given two functions again, we have here function f and function h. Function f at h is equal to x squared plus 5x plus 6. And function h at x is equal to x plus 2. Now let us find out the composition of f at h. Okay? Function composition of f and h. So how was that? So here is the solution. By definition of function composition, we have here f compose h at x is equal to f at h at x. Meaning, our domain now that we're going to use is the function h. This one. Okay, next. Since function h is equal to x plus 2, so now we have here x plus 2. So replace h at x by x plus 2 because that is the given function. Okay, next. Since f of x is equal to x squared plus 5x plus 6, this one. Okay, this one now here, that is given. So therefore, we now have, since we're going to use h, function h, which is x plus 2, we will now substitute the value of x here as x of x plus 2. Okay, so this one here, we have here, we replace x. We replace this x with this value, which is x plus 2. And we have here exponent 2. That's why we have also exponent 2 here. And then we just follow this function, okay, this equation. So we have here x, this is addition, and we have here addition. We have here 5 and 5 also there. And then this time, x, we're going to use x plus 2, this one now. And then we have here addition. So we have there addition. And then we have 6. Okay, did you get that? We just replace x by x plus 2. So this one, I'll repeat, this is now x. We replace it with x plus 2. And then we have here exponent. That's why we have here exponent plus. And then we have here 5. And then we replace x with x plus 2. And then plus 6. Do you have any question on that? Next, we're going to perform the operations. So if you can still remember the square of binomial, we're going to perform the operation of this. X plus 2 squared. And that is now equal to x squared plus 4x plus 4. So you need to have skills in operation of square of binomial. And so we have here, we're going to distribute 5 times x. That's why we got 5x. And we have 5 times 2. That's why we got 10. In this one, we adopt this addition here. So we have here plus, and then plus 6 here. Okay. Next, we combine similar terms. What are the terms that are similar in this equation? On this side of the equation. So, we cannot combine. There are no terms that is the same with x squared. So, we just bring down x squared. And we have here 4x and 5x are similar because they both have x's. So 4x plus 5x is equal to 9x. So we use plus here because the sum is positive. And then we're going to combine terms, constant terms. Okay, so we have here 4 plus 10 and plus 6. 4 plus 10 is equal to 14 plus 6. That's why we got 20 here. Okay, so that is now the answer in the composition of functions f and h. Do you have any question on this? Okay, next. The same given function f and function h. This time, we're going to use the evaluation. Okay, so as you can see here, there is the value of 4 instead of x. We used 4, okay? The value of x now is 4. Now, here is the solution. Step 1, we're going to evaluate, if you can still remember the evaluation of function, h at 4. So, as you can see here, we have h at x is equal to x plus 2. So, we just substitute 4 here. We used 4 in replacement of x. Okay? So, we have now here. This time, this x, replace it with 4. And now, we have the value is 4 plus 6. 4 plus 2, that is equal to 6. Okay? Any question on that? Okay, I'll repeat. You remember your skill, remember the skills in evaluating functions, okay? We just substitute 4 for x, and then we just operate, okay? And then step 2, that is step 1. Step 2 here, we're going to evaluate f at 6. Why 6? Because that is the value of h of 4. Okay, this one, okay? So, the value of h at 4 is equal to 6. That's why we're going to use 6 here. Next, we go back to the function f, which is this one. Okay, so we have here x squared plus 5x plus 6. And then, we're going to evaluate. We just change the value of x, replace it with 6. So, we have here f at 6 is equal to 6 squared. So, we have here x squared. We replace x with 6. That's why we have here 6 squared. And then, we have here 5. Okay, follow this operation, that is addition. We have there 5 and our x now is 6. So we have 5 times 6 plus 6. Okay, next. Since x squared or x times x is equal to 36, that's why we have here 36. And then follow this addition here. 5 times 6 now is equal to 30. That's why we have here 30. And then we have here plus, and of course we have 6. Now here is our final answer. 36 plus 30 plus 6 is equal to 72. Okay? So therefore, the value now of this f composed of h at 4 is now equal to 72. Okay? So you just follow the 2 steps. Do you have any question on this? Okay. That's all for composition of functions. I hope you enjoyed listening. Thank you so much. That completes our lesson for Module 3, which is the operation of function.